If we decide to take out toilet wastes or urine from the wastewater, then we will change the wastewater composition. Especially urine has a lot of nitrogen and phosphorus in it, so we will change considerably the treatment systems after urine separation. If we want to change the waste flows from a household, we have two possibilities. We can reduce the generated wastes in the household, or we can diverse certain wastes. And we will take a look at that, how this can be done. If we separate the toilet wastes, we can handle it as night soil, compost toilets, septic tanks, and so on. And that will affect the wastewater considerably. We can use urine separation, which is used some places. In the kitchen, we have options there. We tend to send a lot of the waste in the kitchen to the wastewater stream when we make dishwashing or clean dishes and equipment. We can also take a considerable amount of that and transfer it to the solid waste fraction if we use what is called clean tech cooking, instead of using the hot water to clean the pots and so on. We can scrape them and put them into the solid waste what we scrape off. That will influence significantly the waste load in the wastewater. We can reuse wastewater from laundry and bath, and we can use garbage grinders where we will increase the amount of material in the wastewater and reduce the amount of material to the solid waste fraction. So if we look at the household, we have two outlets of waste. We have solid waste and we have liquid waste in the wastewater. And we can decide to some degree in which waste stream should the waste from the household leave the house. So we can design our wastewater. We can minimize the waste load to the wastewater if we want that to get a clean wastewater, as clean as possible, by having separated toilets from the wastewater and the clean tech cooking. Or we can maximize the waste loads by using garbage grinders. And let's take a look at how this influences the wastewater. If we separate toilets, we can see the result of the waste load to the wastewater here, that we will reduce the COD and the BOD to half of the amount in traditional wastewater. We will take out the nitrogen, most of it, and the phosphorus, some of it. If we use the clean tech cooking on top of this, we will further reduce the amount of organic material entering the wastewater, also reduce a little bit the nitrogen and phosphorus. But we will end up with an organic load which is between 1/3 and 1/4 of what we have in traditional wastewater. And for nitrogen we have only 10% left, and for phosphorus we might have 20% left. So this is a big change in the wastewater load. If we look at how does that influence the concentrations that we observe, then we have to take into consideration the water consumption in the household. And here we can see if we have a traditional water consumption which might be in the middle, 160 liter per capita per day, we will end up with a COD concentration of 200, BOD 125, 9 nitrogen and 2.5 in phosphorus. In many cases the nitrogen concentration is below what is the effluent criteria for nitrogen from treatment plants, so we do not need any nitrogen removal in this case. If we are very water conscious and only use half as much water, which is very little water consumption of 80 liter per capita per day, then of course we increase the concentrations of the pollutants in the wastewater. So now we have 19 gram per cubic meter of nitrogen in the wastewater. So now we have to treat the wastewater from the treatment plant for nitrogen if everybody saves water. So this is an interesting dilemma we have here. If we use a lot of water in our households, then of course we will dilute the wastewater further. So the effluent guidelines as given in gram per cubic meter have some problems if we reduce water consumption. It is not fair that we then have to treat the wastewater for nitrogen because of the reduced water consumption, because the load that goes out into the receiving water has been minimized and is the same and not dependent on the concentration of nitrogen. If we decide to use garbage grinders and have a maximum waste load to the wastewater, then we can get an idea of the concentration we will have by this. And you can see in the middle case we will have high COD, BOD amounts or concentrations, very high nitrogen and very high phosphorus. And again, if we save water, we will end up with concentrations in the wastewater which are more looking like industrial wastewater from food industry than from households. But this is possible to change the concentrations in the wastewater like shown here on these slides. One typical split of wastewater in household is to split it in black and gray wastewater. And to give you an idea of the concentrations that you will find in these two types of wastewater, this slide shows high and low ranges for concentrations of BOD, COD, nitrogen and phosphorus. The gray wastewater has low concentrations of all components, of course, and the black wastewater from the toilets have the high concentrations. And if we want to treat them separately, it's obvious that the treatment needed will be different in the two cases of black and gray wastewater. Gray wastewater can often be handled locally, may be reused to irrigation and things like that, while the black wastewater has to be handled with care because it has all the microorganisms or the majority of the microorganisms and is infectious.